Hi everyone, this is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. Today onwards we are going to see the Algebra and Numerical Methods unit. Unit 1 is Algebra and Numerical Methods. In that unit we are going to start with the Algebra unit as first. Okay, so today we are going to see the Algebra introduction and then partial fractions as well as the problems based on the partial fractions. So here algebra, you know that you have learnt from the 8th standard onwards till 12th standard you have learnt what is algebra, what is the polynomial equations in algebra, a lot of things you have learnt in the algebraic terms. Okay, so it has coefficients as well as constants combined of the equation is called as algebraic term. We have learned so much of things in the algebra. So here also we are going to see some extensions on the algebra. Okay, so this partial fraction especially you have learnt in the 11th and 12th. So it's very easier. So let us move on to the partial fractions now. So partial fractions, an expression of the form p0 plus p1x plus p2x squared plus p3x cubed and so on plus p and x power n. Here p2, p1, p0, p1, p2, p3, pn are the constants and it is a polynomial in x, and this is denoted by the polynomial p of x. Okay, and x squared, x cube, x power n are the coefficients. Okay, so constant p0, p1, p2, p3 are the constants, and this is called as a polynomial in x. It can be denoted as p of x. Now we are going to see one expression, that is p of x by q of x is called the rational function, where p of x and q of x are the polynomial in x. So p of x by q of x is a rational function we are defining. So it is in the division format, and where p of x and q of x are the polynomial in x. If p of x is lower than, that is the degree of p of x is lower than the q of x, then it is a proper fraction. So if you see the degree of p of x and q of x first when the question is given to us, if the degree is lower than the numerator, degree is lower than the denominator, we can see that is a proper fraction. Suppose if it is a degree is 3 and here denominator is 5, so 3 is less than the 5, so it is a proper fraction. Suppose if it is greater, the p of x is the degree is degree of the p of x is greater than the q of x, then we can call that as a improper fraction. Now we are going to see some cases used on the partial fractions. Depends upon the proper and improper fraction. Proper means the degree should be lesser in the numerator, and improper means the degree should be greater in the numerator. So first we can see the case 1, that is p of x by q of x be a proper fraction. Proper fraction in the sense the p of x should be, the degree of the p of x is greater, or lower, I told, right, lesser. So type 1, if q of x contains non-repeated linear factors, that is q of x can be written as a1x plus b1, a2x plus b2 and so on. That is, it should not be a non-repeated. No terms has to be repeated here. If every term should be different, if it is like that, it comes under the type 1. Moreover, it may be a proper fraction also. First thing you should, when the question is given, you have to identify the whether it is a proper fraction or improper fraction, and then you should see if it is a non-repeated, that is the terms are different, that is the terms are, so if it is a proper fraction as well as the non-repeated linear factors, then it can be written as p of x by q of x is equal to a1 divided by a1x plus b1 plus a2 divided by a2x plus b2 and so on. So here where a1, a2, a3 up to n are constants. Okay, so this is the type 1. So first we have to find whether it is a proper or improper fraction. If it is a proper fraction, then next one is we have to find that it is a non-repeated linear factors, then we should use this method, a by plus by, b by plus c by and so on likewise. Here I have given us a1, a2, an. Next we can see for the type 2, that is if q of x contains a linear factor, linear repeated factor, the factor should be linear and repeated. If it is a repeated in the proper fraction, then it has to be written as q of x is equal to ax plus b the whole power n. So p of x by q of x can be written as a1 plus a2, a1 by ax plus b plus a2 by ax plus b the whole squared and so on. Okay. Next one is type 3. If q of x contains a quadratic equation, if your q of x contains a quadratic equation, we know that ax squared plus bx plus c. If it is like that, which cannot be factorized into linear factors, so I can write like this: ax plus b divided by ax squared plus bx plus c. Okay. Next one is case 2. Case 2 is an improper fraction. If it is an improper fraction, then we have to divide the numerator by the denominator until the remainder is of the lower degree. Then the denominator and then apply the previous steps. So if it is an improper fraction, we have to divide both the terms until the remainder is of the lower degree. So if it is comes under the improper fraction, we have to make it as a proper fraction by dividing both the thing, dividend and divisor. We have to divide it numerator as well as the denominator till we are getting the lower degree in the top term, that is a numerator term. Still that we have to find the values. So after changing into a proper fraction, we can use one of the types. 3 types are there, so you have to use the first one is a type 1 is a proper fraction with what non-repeated. Second one is a proper fraction with repeated. Third one is a quadratic equation. Okay, so only 3 types are there in the partial fraction. Then case 2 is a improper fraction. If it is an improper fraction, we have to make it as a proper fraction by dividing the dividing until we are getting the lower degree in the numerator. Okay girls, so we can move on to the problems now. So it will be easier for you to understand the partial fractions theory part. So if you are thorough in the theory part, it will be easy for you to do the problems. And moreover, it is already have learnt, it seems, so it will be easy for you to understand also. First important question, university question. Resolve 2x minus 3 divided by x minus 2 into x plus 1 the whole squared into partial fractions. Here first we have to see what is the numerator. Degree x value is 1. Next denominator degree is c x plus 1 the whole squared is there. Again one more x minus 2 is there. So if you are x plus 1 the whole squared, if you are splitting, x squared will come. Then there x is there. So 1. So 2 plus 1 is 3. So degree is 3. So here 1 is lesser than the 3. So it is a proper fraction. And see, it is a repeated factor. X plus 1 is repeated 2 times. So we are going to the type 2 formula. So a by x minus 2 plus b by x plus 1 by c by x plus 1 the whole squared. Okay. So the given question can be written as 2x minus 3 by x minus 2 into x plus 1 squared equal to a by x minus 2 plus b by x plus 1 by c by x plus 1 the whole square. Take it as a first equation. Now we are going to multiply throughout by the x minus 2 into x plus 1 the whole squared. So after multiplying on the numerator, it will get cancelled. So 2x minus 3 will get, and here after cancellation a into x plus 1 the whole squared will come. So after multiplying, after cancelling, so we are getting a into x plus 1 the whole square. And here if you are cancelling, remaining term is b into x plus 1 into x minus 2, likewise c into x minus 2. Take this as a second equation. Now we can determine the constants ABC by equating the coefficients of like powers of x on both sides, or by using suitable substitutions of x. Now we are going to find the value of a, b and c. So we are going to substitute some values which is suitable for the x. So we can see put x is equal to minus 1 in the equation 2. So what will happen? Minus 2. So minus 1 in the equation 2 fully. So if you are substituting, so 2 into minus 1 in the place of x, I am substituting minus 1. Okay. So minus 2 minus 3 will come here. This a term and b term will get 0. And 3 term is minus 3c will come. Now minus 5 is the left hand side and minus 3c. Then from this, after reducing, we are getting c equal to 5 by 3. Likewise, we are going to use some different values. Put x is equal to 2 in equation 2. So what will happen? 1 equal to 9a plus 0 plus 0. So a equal to 1 by 9. Now put x is equal to 0 in the second equation. So we'll get minus 3 equal to a minus minus 2b minus 2c. So take the a to be the a and the a terms to be, because we are going to find the value of b now. Already we had find that a and c. So a minus 2b minus 2c equal to minus 3. Take the b term alone in the left hand side. So minus 2b equal to minus 3 into minus a and plus 2c. From that we have to reduce it, and we are getting the b value is minus 1 by 9. Okay. Now you just apply in the first equation 2x minus 3 by x minus 2 into x plus 1 squared. Apply there. So a divided by x minus 2 in the place of a 1 by n, and b value is minus 1 by 9 and c is 5 by 3. So this ends the problem. Okay. So next question we are going, this is also very important. See here, it is given in the partial fraction, right? We are going to solve into a partial fraction. See the given question, 3x plus 7 divided by x squared minus 3x plus 2. they are giving as a quadratic equation, but we can split it easily. So x minus 1 into x minus 2, we can split like this. So if we are able to split like this, no need to go for the ax plus b term. That is a quadratic term type 3 problem. Directly we can move on to this non-repeated linear factor as a first type. So a by x minus 1 plus b by x minus 2, you know how to split this, okay? In the t method or anything like this, you can use it. So x minus 1, now multiply both sides by x minus 1 into x minus 2. So the equation 1 becomes as 3x plus 7, a into x minus 2 plus b into x minus 1. Take this as second equation. Now as usual procedure only, let us take the some absolute values. So put x is equal to 1 in the equation 2. We are getting a value as minus 10. Then put x is equal to 2 in the equation 2. We are getting the b value as 13. Now we can apply the a and b value in the first equation. We are getting the answer. Okay. The first two questions are important questions. And we can move for the third one. Resolve into partial fractions, that is 3x minus 1 divided by 1 minus x plus x squared into x plus 2. Okay, here they have given two terms in the denominator, right? So in the two term they have given, so 1 minus x plus x squared and it's x minus x plus 2. See here, this is a 1 minus x plus x squared is a quadratic term. Okay, we couldn't able to split this, so we have to use the ax plus b format. That's what I have written as a ax plus b here. So type 3. So multiply both sides by this term. So what we'll get? 3x minus 1, then ax plus b into x plus 2 plus c into 1 minus x plus x squared. Take this as the first equation and then put x is equal to minus 2. So we'll get c value is minus 1. Then equating coefficients of x squared on both sides, we are getting 0 equal to a plus c. Now equating the coefficients of x squared in both sides. What is x squared terms here? So x squared terms here this side. So we are getting the a plus c. In this term will become 0 because we don't have the x squared term. So a equal to minus c. So a equal to 1. Now we equating the coefficients of x on both sides. So here we are having the 3x minus 1. So 3 is there. Here x term is 2a plus b minus c after reducing. So we know that b equal to so from this we are getting b equal to 3 plus c minus 2a. Now substitute the a and c value, we are getting the b value as 0. So now substitute the equation, given equation, first equation, that is ax plus b, that is x plus 0 divided by 1 minus x plus x squared minus 1 by x plus 2. So x by 1 minus x square, x plus x squared minus 1 by x plus 2. Okay, so it is a quadratic format. Third question. See the fourth problem, resolve into the partial fractions. Still now, for the past three problems, we got seen that is a case one, that is a proper fraction. Now we are going to see the improper fraction. That is, see the thing, x squared plus x plus 1. Here x squared, here the numerator is equal to denominator. So it is also comes under the, which one? So it comes under the lower degree. Lower degree is less than the degree, or it may be equal to that. If we are having like that, we have to make it into a proper fraction. So maybe for making it a proper fraction, we are having the, I told you that case 2 we have to divide it until we are getting the lower degree. Now the degree is the same here. We are going to change the numerator as a lower degree now. So we are going to divide it. So x squared plus 2x plus 1 divided by this one. So if you are multiplying with this, and you know that this division, after changing we are getting the minus x value. So we can write this as a 1 minus x into this one. 1 minus x into x squared divided by x squared plus 2x plus 1. So which is, take this as first equation now. Now it can be written as x divided by x plus 1 the whole square. That is this one. This one we are taking x by 2, x squared plus 2x plus 1 can be written as x divided by, this can be written as x plus 1 the whole square. So this is written as a by x plus 1 into b by x plus 1 the whole square. Now x is equal to, as usual, we are multiplying and cancelling. We are getting x is equal to a into x plus 1 plus b. Now put x is equal to 1. So b equal to x minus 1. Put x is equal to minus 1. We are getting the value as b equal to minus 1. Now put x is equal to 0. We are getting a plus b equal to, from that a equal to 1. Therefore, this term is 1 by x plus 1 minus 1 by x plus 1 the whole squared. That is this term alone. Which one? This one. A by x plus 1 plus b into x, this term alone. Then we have to apply in the first equation, that is 1 minus this term. This term only we have splitted. Second term. So second term can be spread as like this. So instead of that we can write this one. Okay girls, so thank you so much for watching. If you have doubts, just WhatsApp me. Okay, thank you girls.